Hey, what's going on, guys? Let's see how we can find out the electric field caused by the circle of charge right here. So a ring of charge, right? A ring of charge right here. So let's see how we can find it. So first of all, to find that one, we have to pick up a small area. So let's say this is the area we are picking, right? So if this is what we are picking, and here we are going to have a electric field caused by this, since it is positive going away, right? So it's going away, and this is going to be our DE, and here we are going to have x component of this one, so that is going to be DEx. And if you look at this, this also going to have y components. For example, this also has y components, so let's draw it with a different color. Okay, if you look at this is also going to have y component. And if you look at this, like if you take any part from this below half circle, you will have going toward this direction. So you will have y components in the upper direction, and if you take parts from the above circle, you will have y components in the down direction. So it means upper direction and down direction cancel each other. So y components, all of the y components will cancel each other. But for the x component, it only facing toward this direction, so it will remain. So if you calculate x component, that's gonna give us the electric field. So we only have to care about the x component, and let's find the x component. So here this is x, so let's call this distance ds. If this is ds, then lambda is going to be basically ds dq. Okay, so we are going to have a small charge right here, that's going to be, so we'd say dq, that is equal to lambda times ds. So lambda is basically linear charge density multiplied by this small distance is going to give us the small charge in this particular place. So that's what we need to know, and we have this electric field facing toward this direction. So let's form an equation for this one first. So dE is equal to, so we are using E is equal to kq over r square. So for dE is going to be k dq over r square, right? So this is going to be our equation. In this case, we can replace this with this dq with this lambda ds. So this is going to be k times lambda ds. In the bottom, we are going to have r square. R square, if you look at this, this distance is a, this height is x. So we can say r is equal to square root of a square plus x square. But we have r square right here, so this is going to be a square plus x square. So this is what we have. Now what we have to do, we have to find the x component. So this is d, we have to find the x component. So let's say this is theta. If this is theta, this is also going to be theta, right? And if I take the cos theta, that's going to give us x component. So we can say d e x is equal to d e cos theta, right? So we have theta right here, cos theta. So if this is theta, this is also theta. Cos theta is basically adjacent over hypotenuse. So we can say this one is a over r, right? Adjacent over hypotenuse. So first let's copy the d here. So that is k lambda ds divided by a square plus x square, and cos theta is going to be adjacent over hypotenuse, that's going to be a over r. Instead of r, I can write square root of a square plus x square. So this is going to be a square plus x square, square root of a square plus x square. And here this is power 1, right? This whole thing is power 1, this is whole thing is power 1 half, half. So 1 plus half, that's going to be 3 over 2. So this is going to be k lambda a ds over a square plus x square power 3 by 2. So this is our dEx, but we care about finding the Ex. So Ex also, or you can say E in the X direction. That's going to be basically, if you integrate this one right here, integrate dEx, that's going to give you this value. So let's integrate this one. Let's copy all the dEx right here. That is k lambda a ds over a square plus x square 3 by 2. Right? This is what we are trying to integrate, and this goes from, so the total length of this circle is 2 phi x, radius is x, so the length is going to be 2 phi x, because you know the length of the circle is going to be 2 phi r, so we replace the radius with x. So that's how we got it. So this is going to be from 0 to 2 phi x. Then we can move all the constant to the front. So let's move all the constant to the front. So this is integrating ds, right? ds, except everything we can move out. So we don't have any other s right here. So we can move everything out, and everything except ds out. So this is going to be k lambda a square plus x square power 3 by 2 integral 0 to phi x ds. And if you integrate this one right here, this is going to be simply s. So k lambda a square plus x square power 3 by 2, and this is going to be s from 0 to 2 phi x. For 0 it's going to be 0, but we are going to subtract that from 2 phi x multiplied by this one minus this. So this is going to be k lambda a 2 phi x s minus 0. You don't have to write it because it doesn't make any difference. And then in the bottom we are going to have a square plus x square power 3 by 2. Now here I can do one thing, that k is equal to 1 over 4 phi epsilon. So I can use this one, simplify a little bit. So let's continue this one right here. So if I replace this k with 4 phi epsilon, I can cancel this phi. So lambda a 2 phi x s over 4 phi epsilon naught a square plus x square power 3 by 2. So here we can cancel this 2 phi and this 4 phi. That's going to give us 2 right here, and we will be end up with lambda ax okay, 2 phi x. Actually we are replacing 2 phi x instead of s, so there's no s right here, so this one doesn't come in. So lambda ax divided by 2 epsilon naught a square plus x square power 3 by 2. And if you look at this equation, the first equation right here, lambda is equal to q over 2 phi x, right? So if I replace this one by that one, maybe I can bring the k back to write in a simple form, right? So let's write this one right here. So the last answer, right, it's going to be lambda. Instead of lambda, I'm replacing q over 2 phi x. So q ax over 2 phi times 2 epsilon naught a square plus x square power 3 by 2, and if you notice this one, we are getting 4 phi x plus epsilon again, so we are multiplying this one, right? So 2 phi times 2 epsilon, 4 phi epsilon, so q over 1 over 4 pi epsilon, that's going to be k. So we can write k in top. So this is going to be k qa k q a 2 phi. Also we have an x right here because q is equal to 2 phi x. So this x cancels. So this is going to be k q a on top. In the bottom we are going to have a square plus x square power 3 by 2. Right? That is going to be our final E. So the electric field in this location is going to be equal to kqa over a square plus x square power 3 by 2, and that is our final answer. So let's write this in red box, and this is our final answer. I hope you guys like this video. See you next time.